Have you ever examined whether we're really alone in the universe? Or is there something more to our world than what we see? Imagine if the James Webb Telescope finally reveals that we live inside a black hole. Join us as we explore this crucial news that will make you question everything you thought you knew about the universe. So what exactly are black holes? They're like something out of a terrifying nightmare. Sure, you might have seen them in sci-fi movies, but they are much more frightening in reality. Black holes are not just fictional. They are real, as confirmed by experts. Essentially, black holes are enormous amounts of matter squeezed into an incredibly small region. Picture a star, many times more massive than the sun, all compressed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for quite a while. These objects in space are so massive and dense that they can trap light. The most well-known theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star reaches the end of its life, it collapses, leaving behind a dense core. If the mass of this core is many times that of the sun, gravity overwhelms everything, leading to the formation of a black hole. It's not easy to detect black holes, as they don't emit any light. However, scientists have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole moves through a mass of interstellar matter, it will pull that matter toward it in a process called accretion. Additionally, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays as it does. Black holes also have a huge impact on their environments. They can consume nearby stars, emit powerful gas blasts, and even influence the formation of new stars in some regions, while slowing it down in others. But where do black holes come from? Imagine stars once massive and vibrant meeting their tragic end in a dramatic event known as a supernova. From the remnants of these fallen giants, black holes are born. Most black holes originate from massive stars that end their lives in a supernova explosion. Smaller stars, when they die, transform into neutron stars, which are incredibly dense but not dense enough to trap light. If a star is several times the mass of our sun, it collapses under its own gravitational force, forming a black hole. As these collapses occur, something strange happens near the surface of the black hole. Time itself begins to behave unusually. From the perspective of someone far away, time appears to slow down near the event horizon, the point beyond which nothing can escape. It's as if the star's clock ticks at a different speed compared to our own. Sometimes, when two smaller black holes collide, they merge to form a much larger and more terrifying black hole. If a black hole interacts with a neutron star, it creates a massive nightmare that defies comprehension. Scientists have struggled to comprehend the scale of these immense phenomena for quite some time. Black holes come in two sizes, big and small. But here's the twist. Small is relative when it comes to black holes. Very large black holes, the remnants of massive stars, can be as large as 10 times the size of the sun. There could be up to 10 million to a billion of them in the Milky Way alone. That's a staggering number of black holes that could swallow anything in their path. However, there's something even more enormous on the far end of the spectrum. Supermassive black holes. These can be millions or even billions of times larger than the sun, and they exist at the center of large galaxies, including our own Milky Way. It's like a vast, dark void pulling everything toward it. Famous physicist Stephen Hawking spent much of his life studying black holes. His lectures were always insightful, though some of his theories couldn't be confirmed due to a lack of necessary equipment. But there is hope on the horizon, and it comes in the form of a single scientific instrument, the James Webb Space Telescope, or JWST. This telescope is here to delve into the depths of our universe. The JWST is no ordinary telescope. It's an engineering marvel, a testament to the power of human ingenuity. While other space telescopes have done their jobs well, the JWST is in a league of its own. It makes the Hubble Space Telescope look like a simple speck in the vastness of the universe. The cost of this cosmic miracle is a staggering $10 billion, a number so large it's hard to fathom. This incredible project was the result of collaboration between NASA, the European Space Agency, and the Canadian Space Agency, with contributions from over 300 universities. However, it's not just about the money, it's about the risks involved. The JWST is venturing into uncharted territory, pushing the limits of our knowledge and taking us to places we've only dreamed of. After a successful launch, NASA recently announced that the telescope has enough fuel to last more than twice its base mission life. Since its launch, the JWST has accomplished numerous incredible feats. It traveled more than 1 million miles to reach its orbit around the Sun, where it will remain for eternity. During its journey, it successfully deployed its massive 5-layer sun shield and giant primary mirror, both of which had to be folded to fit into the launch vehicle. Now, after NASA has aligned and calibrated the telescope, it is nearly ready for full operation. One of the most fascinating moments came when NASA announced it had captured its first images of starlight. The first picture taken by the telescope was of a star called HD 8446, which resulted in a mosaic of 18 scattered bright spots from the star's light captured by the 18 mirror segments on the primary mirror. Later, NASA released another stunning image of HD 8446, where 18 unfocused copies of the star were combined into a purposeful hexagonal arrangement. Once the observatory aligns the individual segments of the primary mirror, it will begin the process of stacking the images, merging them into one clear view. Thanks to its cutting-edge technology, the JWST will assist researchers in studying the early stages of the universe, particularly the period following the Big Bang. It will help scientists investigate what happened after the first stars formed, a time known as the epoch of reionization. This refers to when neutral hydrogen was reionized, or made electrically charged again, by radiation from the first stars. This is only possible with a powerful telescope like the JWST. The telescope will also aid in the discovery of exoplanets, which are difficult to identify due to their interaction with their host stars. The powerful sensors of the JWST will be able to observe these planets in more detail, and in some cases even image their atmospheres. Understanding the atmospheres of these planets could help scientists predict whether some of them are habitable. In addition to studying planet formation, scientists are studying galaxies to understand how matter is organized on a large scale. This will help us understand how the universe evolved and how galaxies, like the spiral and elliptical galaxies we see today, developed from different shapes over billions of years. One of the JWST's goals is to look back at the earliest galaxies to better understand this evolution. Researchers are also trying to figure out how we ended up with the variety of galaxies visible today and how galaxies continue to form and evolve. Most significantly, the JWST will help answer some of the biggest questions of all. Are we alone in the universe? And are we living inside a black hole? The JWST has already made some intriguing discoveries. For example, it found compounds called polycyclic aromatic hydrocarbons, PAHs, around supermassive black holes in 3 active galaxies. These carbon-based molecules, with their ring-like structures, are like the goth kids of the universe. They're found everywhere, from distant galaxies to comets and even in our own solar system. PAHs are not only interesting because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal detectable by the JWST's mid-infrared instrument, MIRI. This typically indicates the presence of hot, young stars nearby. However, there's a twist. A curious astrophysicist, Ismael Garcia Bernard from Oxford University, decided to investigate 3 active galaxies: NGC 6552, NGC 70319, and the famous Stephan's Quintet. These galaxies are millions of light years away, buried in the darkness of space. What Garcia Bernard found will make your hair stand on end. In the central regions of these galaxies, where the black holes dominate, he found a ton of PAHs. Sounds great, right? Well, here's where it gets eerie. The radiation near those supermassive black holes distorted the PAHs, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into the void, consumed by the darkness. Now, imagine being consumed by that darkness. But wait, there's a glimmer of hope, or maybe not. The real question isn't whether we're alive, but whether we truly exist. Does everything around us exist because of the black hole we reside in? Everything could be connected within the theory that maybe we're not just living inside a black hole, but rather inside its event horizon, the boundary between the known universe and the unknown. Could it be that everything is part of a black hole? The James Webb Space Telescope is out there searching for answers to these unknowns. Stay tuned, and maybe, just maybe, it will make us rethink everything we thought we knew about existence. The truth could be far more twisted than we realize. In the fascinating world of astrophysics, few topics have generated as much intrigue and wonder as black holes. These enigmatic entities, once the stuff of science fiction, have captivated the imagination of scientists and the general public alike. The James Webb Space Telescope may soon be the key to unlocking some of the universe's deepest mysteries, including the possibility that we are living inside a black hole. So, as we embark on this exciting new chapter of cosmic exploration, remember to ask yourself, are we truly alone in the universe? Or are we just a part of something much, much larger? The concept of black holes has long been a subject of intense fascination for both physicists and the general public. Over time, we've come to understand that these massive objects are not just mysterious voids in space, but powerful cosmic entities capable of influencing the fabric of space-time itself. When we think of black holes, we often imagine swirling vortexes of darkness devouring everything in their vicinity. Yet, the true nature of black holes is far more complex and mind-boggling. A black hole's gravity is so intense that it warps the surrounding space-time, creating what is known as the event horizon, the point beyond which nothing, not even light, can escape. Once something crosses this threshold, it is lost to the singularity at the center of the black hole. This singularity is a point of infinite density where the laws of physics, as we understand them, break down. It's a region where time and space lose all meaning, and the conventional rules of the universe no longer apply. This concept challenges the very foundations of physics, making black holes both a theoretical puzzle and an observational marvel. One of the most captivating aspects of black holes is their effect on the passage of time. According to Einstein's theory of general relativity, time slows down as an object gets closer to a massive gravitational source. Near the event horizon of a black hole, this effect becomes extreme, causing time to appear to stop for an observer falling in. Meanwhile, to an external observer, the infalling object seems to freeze at the event horizon and never quite enters the black hole. This time dilation near black holes has been tested through the observation of objects orbiting supermassive black holes, with remarkable confirmation of Einstein's predictions. Despite their seemingly destructive nature, black holes play a crucial role in the evolution of galaxies and the cosmos as a whole. Many galaxies, including our Milky Way, harbor supermassive black holes at their centers. These colossal objects exert such tremendous gravitational forces that they shape the dynamics of their entire galaxies. In fact, some theories suggest that the formation and growth of supermassive black holes may be closely tied to the formation of galaxies themselves. This interdependence raises the possibility that black holes could be the engines behind the development of the cosmos, acting as a key mechanism in the recycling of matter and energy throughout the universe. Interestingly, black holes also emit powerful radiation in the form of Hawking radiation, a concept proposed by Stephen Hawking in the 1970s. According to this theory, black holes are not entirely black, but instead emit a faint glow due to quantum effects near the event horizon. This radiation, though incredibly weak, suggests that black holes could slowly lose mass and eventually evaporate over time. If this process occurs, it would mean that black holes might have a finite lifetime, contradicting the notion that they last forever. The idea that we could be living inside a black hole challenges our very understanding of reality. If our universe is located within the event horizon of a supermassive black hole, it would mean that our entire existence, from the stars to the galaxies and even time itself, is contained within a cosmic prison. This mind-bending thought has profound implications for how we perceive the nature of existence. It suggests that perhaps everything we observe in the universe is just a small part of a larger unseen structure, a larger black hole whose true nature we may never fully comprehend. Moreover, this theory could have implications for the nature of multiverses. If our universe is inside a black hole, it raises the possibility that black holes could be gateways to other universes, creating a cosmic web of interconnected realms. Each black hole could lead to the birth of a new universe, meaning that the universe we know could be just one of an infinite number of realities within a grander cosmic structure. The discovery of a black hole inside our universe, or the detection of features suggesting such a phenomenon, would revolutionize not just astrophysics, but our fundamental understanding of existence itself. As the James Webb Space Telescope delves deeper into the farthest reaches of space, it could help us answer these existential questions by peering back in time to the very first moments of the universe's existence. The JWST could shed light on how black holes formed, how they influenced the birth of galaxies, and how they may even be interconnected with the broader structure of the cosmos. With its ability to observe the earliest galaxies and the formation of stars, it holds the potential to reveal new insights into the workings of black holes and their role in shaping the universe. In the near future, we may look back on this moment as the turning point in our understanding of the universe, when we discovered that we are not just stardust, but part of a much larger cosmic reality. Black holes are no longer just phenomena to be feared or admired from a distance. They may very well be the key to unlocking the greatest mysteries of existence. And who knows? The James Webb Space Telescope might just lead us to the answer to the most profound question of all. Are we truly alone in this vast, mysterious universe? Or are we simply one of many universes inside an even greater cosmic structure?